We're going to continue on in 12.8 talking about complex numbers. We're going to start out by talking about complex conjugates. And when we talk about these complex conjugates, we're talking about basically the a plus bi, and its conjugate would be a minus bi. So the only change is the sign in the middle. And the reason conjugates are important and that they're useful is because when I take the product, when I multiply two complex conjugates, the number that I end up with at the end is a real number. There's no more I. The imaginary part falls out in the process. So if we just look at a quick example here, if I look at 2 plus 3i times 2 minus 3i, if I go through my distributive property, I have 2 times 2, that's 4. That's going to give me a minus 6i. In the middle, I'm going to get a plus 6i. And then I'm going to get a minus 9i squared. Well, my minus 6i and plus 6i, those are going to zero out. Okay. The minus 9i squared, remember I squared is really negative 1. So this becomes 4 plus 9, and I end up with just the real number 13. So these conjugates are useful, and where they're useful is in dealing with division using complex numbers, looking at quotients. Okay. If you think back to when we did radicals, we had conjugates for radicals that we used to simplify quotients with radicals in the denominator. The same type of situation is going to occur with these complex numbers. I don't want a complex number in the denominator of my fraction. So what we're going to do is we're going to multiply the numerator and denominator by the conjugate of this denominator itself. So since it's just 3i, my conjugate would be negative 3i. So I'm going to multiply in the numerator. Negative 3i times 9 is negative 27i. Negative 3i times 12 would be negative 36i squared. And in the denominator, notice I would get negative 9i squared. Well, when I start to simplify, remember this I squared here is a negative 1, so negative 36 times negative 1 would really give me positive 36 minus 27i divided by this I squared is also just negative 1, so negative 9 times negative 1 would give me positive 9. And then what we do is we split it up and put it back into that a plus bi form. So I would split it up. I'd have 36 divided by 9, which is going to be 4. And I'd have negative 27 over 9, which would be minus 3i. And there is my quotient of 9 plus 12i divided by 3i. So we're splitting it up and dividing each part of the numerator by that real number in the denominator. So we're going to look at example B here, and I would multiply by my conjugate, which is 1 plus 4i in the numerator and denominator. Okay, so I'm multiplying. So in my numerator, when I distribute, I'm going to get 2 plus 8i plus 3i plus 12i squared. Okay, just doing my normal distributive property. 2 times 1, 2 times 4i, 3 times 1, 3 times 4i. In the denominator, notice in the pattern up here at the top, when I multiply conjugates, I end up with a squared plus b squared, which is 1 squared plus 4 squared. That's my a and my b. Okay. So now it's all simplifying. Remember again, I squared is really negative 1. So this becomes a negative 12 on the end, with the positive 2 out front would give me a negative 10. My 8i and 3i gives me plus 11i. And my denominator is 1 plus 16, which would be 17. And now I put it in the a plus bi form. So I'm going to split and have negative 10/17. And then the other side is 11/17, so plus 11/17 I. And there is my complex number that represents the quotient of 2 plus 3i divided by 1 minus 4i. So let's just go through a few more examples. In part A, I have 5 minus 2i divided by 3 plus 4i. So what I'm going to have to do is I'm going to have to multiply numerator and denominator by the conjugate of 3 plus 4i, which would be 3 minus 4i. So in the numerator, I'm going to have to distribute. So I'll have 5 times 3. 5 times negative 4i is negative 20i. Negative 2 times 3 is negative 6i. And negative 2i times negative 4i would be plus 8i squared. And remember, in the denominator, I'm simply going to end up with a squared plus b squared. So when we start simplifying, remember plus 8i squared. Again, remember that the I squared is really a negative 1. So I have negative 8 and 15, which would be 7. Negative 20i and negative 6i is negative 26i. And then the denominator, 3 squared is 9, and 4 squared is 16, and 9 and 16 gives me 25. So when I split this, I have 7 25ths minus 26 25ths times I. And that would be my complex number. If we look at part B, I have a denominator of 6i, so its conjugate would be negative 6i. So I'd multiply numerator and denominator. So 4 times negative 6i is negative 24i. Negative I and negative 6i is negative 6i squared. Divided by, well, there's no a, so I'm simply going to end up with b squared. I've got, this is going to be negative 36i squared. Okay. And then when I simplify, remember that the I squared is really a negative 1, so that's going to become positive 6 minus 24i divided by 36, because this I squared would be a negative 1 as well. So I'd have 6 over 36 minus 24 divided by 36i, and simplifying, that would give me 1/6. Minus, if I divide both of these by 6, I would get minus 4/6, which is really 2/3. Times I. And there's my complex number. In part C, the last one, we'd have to multiply by 8 minus 7i in both cases. Okay. So in the numerator, I'm going to have 64 minus 56i minus 56i and plus 49i squared divided by a squared plus b squared. So when I start to simplify here, this I squared is going to turn this to a negative 1, so that's negative 49, and 64 would give me 15. I've got a pair of negative 56i, so that's minus 112i, divided by 8 squared plus 7 squared, which is going to be 113. And now I split it to the real part, which is the 115 divided by 113, minus the imaginary, which is the 112 divided by the 113, times I. And there's my complex number representing that quotient. Okay. So let's look at a couple more examples, just doing some basic things here. 1 plus the square root of negative 4 plus 3 minus the square root of negative 9. The first thing we would want to attack here is the fact that we've got negatives under the radicals. So that would become 1 plus, remember the I would come out with the negative, so I could think of this as I square root of 4, but the square root of 4 is 2. So it becomes 1 plus 2I. Plus, over here, my square root of negative 9, remember the negative, square root of the negative would become I. The square root of 9 is 3, so I'd have 3 minus 3I. And I'm adding, so I'm just combining like terms. I'm adding the 1 and the 3, which gives me a 4. I would add the 2I and the negative 3I, which gives me a minus 1I. And I have 4 minus I. Okay. What about in number 2? In number 2, we've got a product of complex numbers, but again, we've got some radicals that have negatives. So I would rewrite those. This would become minus, the square root of negative 16 would be I, and the square root of 16 is 4, so it's 4 minus 4I, times 2 plus, the square root of 25 is 5, and the square root of negative 1 would be I. So now from here, we're just doing straight distributive property. 4 times 2 is 8. 4 times 5I is plus 20I. Negative 4I times 2 is negative 8I. And negative 4 times I times 5I is going to be minus 20I squared. So I've got 8, 20I minus 8I is a plus 12I. At the end, I'd have 20 times negative 1, which is really a positive 20. So when I combine like terms, I can combine the positive 20 and the positive 8, which gives me 28. And then I have the plus 12I. Okay. So, just some basic simplifying using the negatives under the radicals and using the multiplication or the addition and subtraction of complex numbers here. All right, last one. We want to rationalize, or we want to simplify this quotient. So I would have to multiply top and bottom by the conjugate, which would be a positive 2I. So I'd have 3 times 2I, which is going to give me 6I. I times 2I is plus 2I squared. And negative 2I times 2I would be negative 4I squared, which remember is really negative 4 times negative 1. This is really 2 times negative 1. So I have negative 2 plus 6I divided by 4. And now remember, I'm going to split them. So negative 2 over 4 is negative 1/2. 6 over 4 is 3/2 times I. Okay. So we'll do some more of these problems on the worksheet in class tomorrow. See you then.